So given a large sample of adult men where we measure their heights, it is known that the heights will take on a normal distribution with an approximate mean of 69 inches and standard deviation of 2.8 inches. Knowing this, we want to find the z-score of a man that would be 67.9 inches tall, so a little bit less than the mean. Let's look at a graph to help us visualize what we're looking for. So here's an illustration of what a large sample of adult males' heights might look like. Since they are normally distributed, it would take on a bell-shaped curve like this line graph here. And the highest point would be the median value of 69.1 inches here, so about 69 inches. A measurement of 67.9 inches would be just slightly to the left, between 65 and 69. And we want to know what's the z-score for this value, and that's looking at how far this value is from this mean value here, since we know that mean and median would be approximately the same in a normal distribution. So we know that the standard deviation was 2.8, so we're finding out about how much of a standard deviation would this value, 67.9, be from that mean of 69.1 or 69. So we're going to use this z-score formula to find the z-score value. The data value is the 67.9 inches. So the z-score equals the data value of 67.9 minus the mean of 69 and the standard deviation 2.8. We'll divide by that value. There. We can use decimals to find this number. We have the fraction 67.9 minus 69 on the top, divided by 2.8 on the bottom. So according to Desmos, we have negative 0.3928857, which is approximately negative 0.4 if we round to one decimal place. Approximately negative 0.4. So that's the first question. The next is, what percentage of men are less than or equal to 67.9 inches tall? So let's look at our graph again. The percentage of men that are less than 67.9 inches tall would be the men that are on the left side of this 67.9 and underneath this line here that represents the distribution of the data. So it's the percentage of the graph that's in this area here. So we can find that by finding the percentile given the z-score. So the percentile of a data value is the percentage of data that is less than or equal to that data value. So if we just find the percentile that corresponds to this z-score, we can find the percentage of men that are less than or equal to 67.9 inches tall. So we find that by using our percentile chart. From our chart, we can see that negative 0.4 corresponds to a percentage of about 34.46. And 34.46 rounds to approximately 34.5. So we do get this percentage for the percentage of men that are less than or equal to 67.9 inches tall. What if we want to find the percentage of men that are taller than 67.9 inches? Looking at our graph again, we found that 34.5% were less than 67.9. So this would be about 34.5% here. If we want to know the ones that are taller, then we're finding this area here on the other side of 67.9. So we want to know what is this whole area here. Well, 100% of the data would be under this green line here that represents the distribution. So if we subtract the data that's in this area, that 34.5% from 100%, then what's left will represent these values that are more than 67.9. So that's how we would subtract 34.5% from 100 to find the ones that are more. So we find this value by taking 34.5% from 100%. 100%, which would be all the data, minus the 34.5% that are shorter than 67.9 inches, then what's left is 65.5%, which would be more or taller than 67.9 inches. So that's where we get this value, subtracting this one from 100%. So a data value of 67.9 inches tall corresponds to a z-score of negative 0.4, which we saw from the percentile chart corresponds to 34.5% that would be less than that height, less than or equal to, and what's left is 65.5% that are more than that height. So percentiles and z-scores give us a way to see how different data values in a set that is normally distributed compare to the mean of that set.